Welcome to the Teja Statistics. Today we are learning in binomial distribution. Recurrence relation for the movements in binomial distribution. First of all, you have to write the PMF of the binomial distribution is given by P of x equals to NCx p to the power of x q to the power of n minus x, where x can takes the values from 0, 1, 2 and so on up to n, and p is always lies between 0 to 1 and q equals to 1 minus p. So the relationship between the movements and expectation, mu r is equals to expected value of x minus x bar whole to the power of r. If you consider the expectation e of x minus, in place of x bar you can write expectation value of x whole to the power of r. For the binomial distribution, e of x value will become np. So only if you consider the expectation summation x minus np whole to the power of r into p of x. So what is our p of x? P of x is as per the binomial distribution and cx p to the power of x q to the power of n minus x. So if you consider that one, so you substitute the p of x value over here, and x can takes the values from, where x can takes the values from 0 to n. So here the parameter value to find out the recurrence relationship, the parameter value you have to consider, the parameter value is p. So we have to differentiate with respect to that. Okay, so in binomial distribution, in binomial distribution p is the parameter. So different, in binomial distribution p is the parameter, so differentiating with respect to the p, so d by dp of mu r LHS, d by dp of that whole function again, where q can be written as 1 minus p. Okay, so to put the terms where we don't have the p values, so in the function in cx there is no p value, so for differentiation we can use that one. You can apply uv formula over here. X minus np whole to the power of r, putting as a constant, d by dp of p to the power of x and 1 minus p whole to the power of n minus x, we are differentiating, and p to the power of x 1 minus p whole to the power of n minus x, uh, we are putting constant, and d by dp of x minus np whole to the power of r we are using. So according to that differentiation, summation remains same, x minus np whole to the power of r remains same. So uv formula again you have to apply here, p to the power of x fix, n minus x 1 minus p whole to the power of n minus x minus 1, but x is not x, you have to differentiate with respect to the minus 1. Next similarly p of x putting as a constant, uh, 1 minus p whole to the power of n minus x is putting as a constant. So whole term you can do the differentiation, then you will get the values like this. Okay, so in this whole term you can able to uh, do the one common thing. So summation ncx is all, and x minus np whole to the power of r if you common, minus p to the power of x 1 minus p whole to the power of n minus x divided by, from here you can write 1 minus p n minus x. plus x into p to the power of x 1 minus p whole to the power of n minus x divided by p. From here you can write minus nr minus nr into x minus np whole to the power of r minus 1 p to the power of x 1 minus p whole to the power of n minus x. So you can do the common and you will get the terms like this: x divided by p and n minus x divided by 1 minus p and minus nr divided by x minus np. So if you do the common and simplification overall here, you will get the terms and you will get some uh, cancellations and you will get the value like this: summation x minus np whole to the power of r ncx p to the power of x 1 minus p whole to the power of n minus x. So common value x minus np divided by p into 1 minus p minus nr divided by x minus np. So which is in the form of if you multiply that function, the summation, to this value, then you will get like this. So when bases are equal, power should be added. So we are putting r plus 1 over here and ncx p to the power of x 1 minus p whole to the power of n minus 6 remains same, and p of 1 minus p also remains same, minus n r summation here, the x minus p in the division value denominator. So this will become x minus np r minus 1. Okay, and ncx p to the power of x 1 minus p whole to the power of n minus x. So this is in the value of mu r plus 1, this is in the value of mu r minus 1, which is our first formula. So this is in LHS we already have d by dp of mu r. So what we need to calculate here is mu r plus 1. So and put all remaining values this side. So 1 divided by p of 1 minus p mu r plus 1 equals to, this term is moving this side, so getting the value of plus. Okay, d by dp of mu r of nr into mu r minus 1. So which is equals to mu r plus 1 is equals to p into q, since q equals to 1 minus p. So pq of d by dp of mu r plus nr into mu r minus 1. Very important relation for the binomial distribution, the recurrence relationship. This one you have to derive. Okay, so differentiating with respect to the parameter recurrence relationship. Thank you. Please do subscribe and like and share. Thank you.